Hello, this is a quick PowerPoint on DEPT or DEPT spectroscopy. You can see it called either one. They're slightly different in the pulse sequence and the way the experiments run, but you get very similar, so you get the same kind of information. So if you remember, on carbon-13, we always just get the number of carbons in the chemical shift, whereas in proton NMR, we get multiplicity and shift and number of hydrogens, unique hydrogens, as well as the number of hydrogens on a particular peak. We can actually integrate. So we can't really integrate in carbon-13 NMR, but we can use this pulse sequence, distortionless enhancement of polarization transfer, or a different polarization transfer, to figure out how many hydrogens are on each carbon in the spectrum. And the top spectrum is showing you an DEPT. The DEPT spectra show quaternary carbons, methylene carbons. So quaternary means no hydrogens. Methylene is a carbon with two hydrogens, sorry. So this is carbon with no hydrogens. This is a CH2. A methine is a CH, and a methyl is a CH3. So the odd number of hydrogens, phase positives, and the 0 or 2 will point down. The DEPT 135 gives you very similar, but the quaternary do not show up. Okay. So we'll look at a couple of examples. So sometimes DEPT can be presented to you as each individual angle. So on DEPT 45, we're seeing all of the peaks with hydrogens, but they're not phased up or down. For DEPT 90, we see only the CH2, or the CH, sorry. So these are the CH. This is all of the carbons with hydrogens. All with the hydrogen. And the DEPT 135 shows you the CH2s pointing down. It does not show you anything that doesn't have a hydrogen, so you'll notice the carbonyl is missing from all of the depths. And then these are the CH and CH3. This is the most common one that you'll get. The CH2 pointing down, the CH and CH3 is pointing up. So in these, you don't get the carbonyl. So if we go to try and solve the problem using this, it gives us a little more information. So if I have a C8H10, first thing I want to do is calculate the degrees of unsaturation. So this should be 18 minus 10 divided by 2. So that's 8 divided by 2 is 4. So I've got 4 sites of unsaturation. I have a set of peaks here between 160 to 180. All of that seems to indicate an aromatic ring. I have no other heteroatoms, so I think I probably have an alkyl group hanging off of there. And this is 6 carbons, so I have 2 carbons left. One's pointing up as a CH or CH3. And one's pointing down, this is a CH2. So this is probably my ethyl benzene. So here's another one, but now I've got some oxygens in here. Let's go through it, the DU. So this would be 12, well, 20, sorry, 22. 10 times 2 is 20 plus 2. Minus 12 over 2. So I get 10 divided by 2. So I have 5 sites of unsaturation. So I've got an aromatic ring and something else. I've got 2 oxygens, and I don't see, because I've only got DEPT, I don't have any carbon. I'm thinking maybe I've got a carbonyl. But I have a carbon pointing down, so that's a CH2 next, and it's at 60 something, so it's next to an oxygen. I have another CH2, and I have a CH3. So you could come up with a couple of possible, but with just the DEPT and the molecular formula, this would be a very reasonable structure to draw. So the propyl benzoate. So there's a number of practice problems in your workbook. There's so I will go try doing some of those, and there's links to other websites that have practice with the DEPT.